next topic for the AP Unit 1 is photoelectron spectroscopy. There's a lot of graphs that we see in AP chemistry that we just have to be able to read them. We don't have to understand how they're completely obtained. That's a higher level of chemistry than AP expects you to be able to do. But you have to understand all these graphs have some sort of analyzing technique that has an output to some sort of computer. So these graphs that we're seeing would be obtained using some sort of computer software that's output after it goes through the process. So in this one, photoelectron spectroscopy, or it's usually shortened to PES, is used to figure out the bonding energy of electrons in an atom. So again, we got to think about the makeup of an atom. You have your nucleus in the center that is positive. You have your electrons that are orbiting. The thing that holds the atom together is the attractive force between that positive nucleus and those negative electrons. And so the bonding energy is going to be greater the closer you are to the nucleus. So your electrons closest to the nucleus will have the highest bonding energy. Your valence electrons will have the lowest bonding energy. Again, this technique uses a machine. You can look it up. It's a big giant process, and it's really just analyzing the kinetic energy. How much energy does that electron have? And then again, electron configuration is what we see on the PES graph. So if you don't know how to do electron configuration, you cannot observe what's going on these graphs because you're going to be seeing peaks that represent the different orbitals. The Aufbau principle, I mentioned this in my last lesson. The Aufbau principle is one of the principles we use when we are doing electron configuration. It just states that electrons fill the lowest energy level, and then once that level is filled up, then it goes to the next energy level. And we're going to still be looking at that to determine what the orbitals are. Your y-axis is going to have weird peaks on it on the graph. Those represent the relative number of electrons in each orbital. We rarely see the d orbital in these PES graphs for AP level. And so most of our peaks are going to have either 2 for the relative number of electrons if it's an s orbital, or 6 if it's a p orbital. If we did see a d orbital, then the peak would be 10 up to 10. And we never see an f for PES for AP chemistry. The x-axis is your bonding energy. This is just saying how much energy is being, does the electron have by binding it to the nucleus. And so the greater your bonding energy, the closer the electrons are to the nucleus. So let's look at a couple of these graphs. So in this one, you have your y-axis again is your relative number of electrons. You're going to have these weird peaks throughout your graph on these PES graphs. And it tells you the relative amount of energy that each of these have. And this is my binding energy. And so when I'm looking at these graphs, I have to look at my x-axis scaling. So this is 0 and this is 10. We want to look at the one that has the greatest bonding energy, and that tells us where to start our electron configuration. They are going to be given to you for complete electron configuration, so they will show you all of the electrons from the nucleus out. And so since this one has a bonding energy of 6.26 and this one only has 0.52, this is where we're going to start. So based on Aufbau principle, the very first thing that we are going to fill in is our 1s. And so I typically just label on my graph. So above this, I would just label this is my 1s2. I know it's 2 because that's what my peak tells me it is. I can also tell it's 2 because it's taller than, it's double this one. So this one is 1, this one is 2. And I know it's 1s because it has the greatest bonding energy. I start at my innermost electrons. So this is my 1s2. And then this is going to be my 2s1 because, again, in Aufbau principle, I go from 1s to 2s. If I add my exponents, then that tells me the identity of the element. And so if I have an element that has 3 electrons, if I look on the periodic table, that element is lithium. And that's typically what it's going to give you, is it's going to ask you what is the identity of the element. Or it might say, how many electrons does this have? How many valence electrons? It could ask you about the number of neutrons in this element. There's a lot of different ways they can ask you questions. So total electrons I have is 3. And if it's a neutral atom, then 3 electrons equals 3 protons. And my protons are my identity of the element. If it asks me for valence electrons, then I'm only looking at my 2s orbital, and it only has 1 electron. So lithium only has 1 valence electron, and it has 2 inner electrons. So just depending on the graph, they just ask you different types of questions. Let's look at another one. So this one has more than one row. All of them are relative number of electrons, but the scaling is different. And so they typically have it from 0 to 10, from 10 to 100, and then from 100 to 1,000. That's how they usually scale these PES graphs. And so down here I have 0 to 10. Up here I have 10 to 100. Again, we always start at whichever one has the greatest bonding energy, because that is going to be the thing that is in closest to the nucleus. So this one is 19.3, this one's 1.36, and 0.80. So this one is going to be my 1s, so 1s2, because it has 2. That makes this be my 2s2, because as far as energy, the bonding energy is getting a little bit less. And the least bonding energy is this one. So if I've already filled up my 2s, then the next place I go to for Aufbau is my 2p. Again, when we're talking about these PES graphs, it takes less energy to take my outermost energy electrons. And so that's the reason as I get further away from the nucleus, that bonding energy is decreasing, which means that's going to be the first electron I lose. And then it would be these. So I have an electron configuration 1s2, 2s2, 2p1. This one is referring to boron. I can do it from my location. This has 1, 2, 3, 4, 5 total electrons, which means it has 5 protons, which is how many boron has. If I was asked about valence electrons, it is the outermost energy levels, s and p orbitals. And so I have 2 plus 1 gives me 3 valence electrons for boron. These are my innermost electrons. So let's do one more. So again, this one says the spectrum below is for which element, and explain your reasoning. We have to look at the scaling. So on this graph, it goes 0 to 10, 10 to 100, 100 to 500. You always start at whichever one has the highest bonding energy. So 151 is the highest. So that makes this be the 1s2. Based on Aufbau, I have to fill to the next highest. So that is my 2s2. And then down here, I have, this is my next highest. And you'll notice this peak is higher than any of the ones that we've seen. It has a total of 6 in it. Aufbau would go 1s, 2s, then 2p. So this is actually my 2p6. And then my next one would be 3s, and then 3p. It is in the order from the periodic table that I showed you guys with electron configuration. And this is how Aufbau fills in, because these are going to be the order in which they have the greatest and least energies. Again, this bonding energy is the lowest, which means this would be the first electron that would be taken, and then it would go to the 3s orbital and take those until it became stable. Stability comes from losing enough electrons to have an electron configuration like a noble gas. So this has 1s2, 2s2, 2p6, 3s2, 3p1. If I look on the periodic table, that one is aluminum. Is at my 3p1. It has a total of 13 electrons. If we count it up, 4 plus 6 is 10, 12, 13, which means it also has, if it's neutral, 13 protons. Explain my reasoning. I could say because the electron configuration matches that of aluminum's, because it has a total of 13 electrons and 13 protons, which makes it be aluminum. There's a lot of ways you can prove your reasoning. If we're talking about valence electrons, we look at the outermost s and p. So this would have 2 plus 1. So this would have 3 valence electrons in aluminum, which matches what we know about group 13 elements have 3 valence electrons. So these graphs are not terribly difficult, but you have to know where to start. And you always start from the one that has the highest bonding energy and just work your way through following that electron configuration and filling in until you get to the end. There are times that they do not have any numbers at the top of these peaks. If there are not numbers at the top of the peaks, you have to look and relative to each other, figure out what the height of that peak would be. So like if I looked at this one first, I can obviously tell that this one is half as much as that one, and this one is 3 times as tall as that one. And so you can figure out based on the heights how many electrons they have. And if you start at the one with most bonding energy, then you can use your knowledge of electron configuration, because this has to be 1s, that has to be 2s, that has to be 2p. And so once I figure that out, I can figure out that the height of this has to be 6, because we have to fill in our p orbitals with 6 before we go to the next one. So use your knowledge of electron configuration to try to understand these PES graphs.